In Module 3 of Chapter 24, we'll continue our study of the short rate models introduced in Module 2. We're going to discuss three bond pricing models that are fairly well known in the practice. The first is the Randleman-Barter model, which will then follow up with the Vasicek and the Cox-Ingersoll-Ross model. Each model we will see has some advantages and some shortcomings. And again, a point I made in the last module was that in search of the perfect interest rate pricing model is an ongoing search. These models differ in their specifications of the parameters of the short rate process, those being the coefficient alpha of R or A of R, the coefficient of dz being the sigma term, and also the Sharpe ratio function, phi of R. The simplest model, before we turn to those three, would be just arithmetic Brownian motion, whereby we simply say dr has a drift of A and a certain volatility. And this is a somewhat naive process for interest rates because it's predictable that with this process the interest rates at time t will be normally distributed with a mean of R0 plus AT and a variance of sigma squared t. And one might think that as we go through time to have an increasing variance of interest rates, inevitably they'll be negative with significant probability, and this may not be a practical model. As I mentioned, the short rate can be negative. Another shortcoming of this model is that the drift is constant, that at each period of time, or each unit of time, the drift is 1 unit of A. Mean reversion is a more popular form of a drift, and we've seen this in other models in earlier modules, and that is the idea where there is some equilibrium level of interest rates that we believe interest rates tend to revert to, so that when they get too high, there tends to be a downward drift toward that average rate. And if they get too low, they tend to drift upward. And mean reversion is quite popular in interest rate models. And finally, this naive model we just looked at has a constant volatility, and that is whether interest rates are high or low, the volatility is always sigma. And if even the most casual analysis of historical data would reinforce the notion that interest rates tend to be more volatile when rates are high than when rates are low. The Randleman-Barter model solves some of these problems, and it's our old friend, geometric Brownian motion, introduced in a interest rate or a short-term interest rate context. You'll notice the parameters, the coefficient drift is AR and sigma R. So this is identically the Black-Scholes model for stock prices, in fact, applied to the short-term interest rate. There's some objection to this model because interest rates can be arbitrarily high. In practice, again, we would prefer a model that had some mean reversion to prevent them from getting too high.